Assalamu alaikum, Hassan Termes from Almaty Schools. Today we will start by part 3 from our lesson, Real Numbers, which is chapter 2 in our textbook. Objectives. At the end of the video, the student will be able to compare expressions containing radicals, distinguish between a rational number and an irrational number, and as usual, we need the following materials: the book, draft papers, pen, and calculator. First of all, we will start by comparison of two radicals. We have a and b are two positive numbers, and we have a less than or equal to b. This means that radical a less than or equal to radical b. Examples: since we have 49 less than 52, then we have radical 49 less than radical 52. Therefore, 7 less than 2 radical 13 after we simplify radical 52. If we have radical 6 less than radical 10, then we get 6 less than 10. To compare, for example, 5 radical 2 and 4 radical 3, first step, we write the numbers in the form of radical a, where a is a positive number. If we have 5 radical 2, we move 5 into the radical to get 5 power 2. We did that in the previous videos. When we have a squared number inside a radical, we move it outside and we cancel the power 2 to get 5. But here we use this property in opposite direction. So we move 5 into the radical to get 5 power 2, and finally we multiply to get radical 50. And here we have 4 radical 3, we move 4 from outside into inside to get 4 power 2, and finally to get radical 48. This is the first step. Write in the form of radical a. The second step, we compare radical 48 less than radical 50, because 48 less than 50. Then 4 radical 3, which is radical 48, less than 5 radical 2, which is radical 50. This example, if we change to radical 3 into single radical, we will get radical 12, and 3 radical 2, we change it to get radical 18, and then radical 12 less than radical 18. This means 2 radical 3, which is radical 12, less than 3 radical 2, which is radical 18. Application: stop the video and try by yourself. And this is the solution. This is the first one. We change 2 radical 5 into radical 20 and 2 radical 6 into radical 24, and radical 20 less than radical 24 because 20 less than 24. Finally, we get 2 radical 5, which is radical 20, less than 2 radical 6, which is radical 24. The second one, we convert 4 radical 2 into radical 32 and 6 into radical 36, and we get radical 32 less than radical 36, and if we simplify, we get 4 radical 2 less than 6. The third example, we have minus 5 radical 2. Here we move 5 into the radical to get 5 squared times 2, which is 50, and keep the minus outside to get finally minus radical 50. Here the same to get minus radical 54. Radical 50 less than radical 54. But here pay attention, minus radical 50 is greater than minus radical 54. Therefore, minus 5 radical 2 is greater than minus 3 radical 6. Now we will talk about rational numbers. A rational number is a number that can be written in the form a over b, in the form of a fraction. A and b are two integers. Integer mean no decimal point in this number, and this number may be positive, may be negative. And be careful, b does not equal to 0 because b is the denominator. Examples: every integer is a rational number. For example, 6 is a rational number. Why? Because we can write 6 in the form of a fraction, which is 6 over 1. Also, every decimal is a rational number, because 3.25, the decimal number, we can write it in the form 325 over 100 and simplify it to get 13 over 4. which is in the form a over b. So, since the decimal number can be written in a form of a fraction, we can say a decimal number is a rational number. And every unlimited repeated decimal, also it is a rational number. For example, 2.3 bar, and if we use a calculator and we divide 7 over 3, we will get 2.33333 unlimited, which is a 3 bar. And this is a rational number because we write it in a form of fraction. Radical 2.25 is a rational number also, since if we write radical 2.25 we will get 1.5, and 1.5 can be written in a form of a fraction 3 over 2. Pay attention, we have for each type of numbers a specific symbol. Integers, we write Z. Z is a symbol of the integers, and D is a symbol of decimal numbers, Q is a symbol of rational numbers. The natural numbers are the positive integers, so all the integers which they are positive and not negative, we can say that they are natural numbers. How to write an unlimited repeated decimal as a fraction? We have some numbers and we have bar in each of the following numbers representing the repetition of this number, and then to write each of the following numbers in a form of a fraction, we can write 0.5 bar 5 over 9, 0.32 bar 32 over 99. Pay attention, the number below the bar, we write it in the numerator. We have 5 here and we write 5 in the numerator. We have 32, we write 32 in the numerator. Since we have only one digit after the point, we write only 9. We have 2 digits after the point, we write 99. Okay, 2.6 bar. We decompose this number into 2 plus 0.6 bar. We write 2 plus 6 over 9. 0.6 bar, we can write it in the same way when we write 0.5 bar. Then we calculate these two numbers to find 8 over 3. 4.25 bar. Pay attention, here the bar notation is only for 5. So we decompose this number as follows. 4.2 plus 0.05 bar. Now 4.2 we can convert it into a fraction as usual, 42 over 10. Okay, here 0.05 bar. We write it 5 over 90. Why? Because 0.05 bar, if we move the point into the right one digit only or one time, then we have 0.5 bar times 10 to the power minus 1, because we move the point into the right. Then we write 0.5 bar 5 over 9 times 10 to the power minus 1. If we move 10 to the power minus 1 into the denominator, we get 10, and finally we get 5 over 90. Here we have 3.511 bar, 3.5 equals to 35 over 10, 0.011 bar, same, we can decompose it as follows. We can move the point into the right only one time and multiply by 10 to the power minus 1. Then we move 10 to the power minus 1 into the denominator after change 0.11 bar into 11 over 99 to get 11 over 990. Application. Stop the video and try by yourself. The solution. First one, 3.27 bar. We decompose this number to get 3 plus 27 over 99 and calculate to find 36 over 11. 4.5, 512 bar. We decompose this number as follows. 4.5 and we get 45 over 10. 0.0512 bar, we get 512 over 9990. Pay attention here. We can understand this number as follows. We have three numbers having a bar notation, so we write these three numbers in the numerator. We have four numbers after the point, so the denominator should contain 4-digit number. Three numbers of these four numbers containing bar, so 999, and finally we write 0. Another example, 5.05 bar, we decompose this number as follows. We write 05 in the numerator, but 0 to the left we ignore it. And we have two numbers having a bar notation, so we write 99 and then add to find 500 over 99. Now we will talk about irrational numbers, numbers that cannot be written in the form of a over b. We call that these numbers are irrational numbers. For example, radical 2 or pi. Radical 2 having an unlimited numbers after the point. Also pi having unlimited numbers after the point. And these numbers are not repetitive, so they are irrational numbers. To know if a radical a is a rational or irrational, a is a positive number. First of all, we write the prime factorization of a, and then we check the exponents of this prime factorization, if all are even or not all are even. How can we do that? For example, radical 7056. 7056, we can write it in this form, 2 power 4 times 3 power 2 times 7 power 2. If we look for the exponents, all these exponents are even numbers. So we can say that radical 7056 is a rational number because all the exponents are even. Notice that if we simplify this number, we will get 84, which is an integer, and integers are rational numbers. So we can say that this number is a rational number. This is another way to say that this number is rational or not. Radical 108 is an irrational number. 108 equals to 2 power 2 times 3 power 3. Here the exponents are not even. We have only one even, but the second one is odd. Therefore, we can say radical 108 is an irrational number. Another way, we can simplify radical 108 to get 6 radical 2. And we know radical 2 is irrational. Therefore, 6 radical 2 is irrational. This is another way to say if radical 108 is rational or irrational. Now, all the numbers we have seen, natural, integers, decimal, rational, irrational, all these numbers are called real numbers. Application, stop the video and try by yourself. Now, the first number, rational or irrational, 3.26 equals to 326 over 100, which is 163 over 50. So we can write it in the form of a fraction. So it is a rational number. The second one, we have irrational number plus 1. And when we add an irrational number to the integer, we will get finally an irrational number. So this is an irrational. Radical 245, we write the prime factorization. One of the exponents is odd, so not all the exponents are even. Therefore, radical 245 is irrational. Since 7.5 bar equals to 68 over 9, which is a fraction, then we can say 7.5 bar is a rational number. Finally, radical 576 equals to radical 2 power 6 times 3 power 2. All the exponents are even. We can say that radical 576 is a rational number. And this is your assignment. And this is the summary of the whole lesson. And thank you for watching. Assalamu alaikum.